Differentiation by rule, extra examples. Part 1. So this is a similar formula that you will see in your formula book for basic differentiation. But the rule in words is multiply by the power, or you could say bring down the power and reduce the power by 1. So differentiate with respect to x. So y equals x to the power of 5. So we bring the power down in front, the 5 comes down in front, we reduce the power by 1. 5 minus 1 is 4. So dy dx, the derivative, is 5x to the power of 4. Part 2, y equals minus 3x squared. So we bring the power down in front, the 2 comes down in front, we reduce the power by 1. So we have 2 times minus 3 is minus 6, we stick on the x, and 2 minus 1 is 1, and 6x to the power of 1 is just 6x, so we end up with minus 6x. Part 3, y equals 5x. So it's important to note that y equals 5x is the same thing as y equals 5x to the power of 1. So we bring the power down in front, the 1 comes down in front, we reduce the power by 1. 1 minus 1 is 0. So we get 1 times 5x, which is just 5x, and 1 minus 1 is 0, so to the power 0. And we know anything to the power of 0 is equal to 1, so 5 times 1 is just 5. Or what you could have done very easily was just cancelled off the x. So anywhere that we have just an x to the power of 1, the derivative, you just simply cancel off the x. And fourth, we have y equals 8 over x squared. So y equals 8 over x squared is the same thing as 8x to the power of minus 2. So we're just rewriting that using our powers rules, our indices rules. So then everything else is the same. We bring the power down in front, minus 2 comes down in front. We reduce the power by 1. So we have minus 2 multiplied by 8x is minus 16x. And minus 2 minus 1 is minus 3. And then we rewrite this again using our power rules to get minus 16 over x to the power of positive 3. Differentiate with respect to x. So y equals 6 root x. So 6 root x is the same thing as x to the power of a half. So the half comes down in front, we reduce the power by 1. A half minus 1 is minus a half. So half of 6, half multiplied by 6x is 3x. And a half minus 1 is minus a half. And then we rewrite this using our powers laws. So 3x to the power of minus a half becomes 3 over x to the power of positive a half. Next we have y equals 2 over root x. So we rewrite this as 2x to the power of minus a half. So the minus comes from the fact that we have a divide sign here. And the root x becomes x to the power of a half, so we end up with 2x to the power of minus a half. So we bring the power down in front, minus a half comes down in front, reduce the power by 1, minus a half minus 1 is minus 3 over 2. And then minus a half multiplied by 2x is minus 1x. So we have minus 1x to the power of minus 3 over 2. We rewrite using our powers laws, and we get 1 over minus x to the power of positive 3 over 2. Next we have y equals 6 over x to the power of a third, which we rewrite as 6x to the power of minus a third. We bring the power down in front, we reduce the power by 1. So we get minus a third times 6x to the power of minus a third minus 1. Minus a third times 6 is minus 2x, and minus a third minus 1 is minus 4 over 3. And then we rewrite using our powers laws to get minus 2 over x to the power of positive 4 over 3. And lastly, we have y is equal to 7. Well, y is equal to 7 is the same thing as y is equal to 7x to the power of 0, because x to the power of 0 is equal to 1. So this is really 7 times 1, which is 7. So we bring the power down in front, the 0 comes down in front, we reduce the power by 1. 0 minus 1 is going to be minus 1. And anything multiplied by 0 is just going to be 0. Or another way of looking at it is you can't differentiate with respect to x if there is no x. So y is equal to 7, the derivative will just be 0. So anytime you have a constant and you want to differentiate it, you automatically just get 0. If the expression to be differentiated contains more than one term, just differentiate separately each term in the expression. So find f prime x for each of the following. So f of x is equal to x plus 1 over x squared. So first of all, we're going to rewrite 1 over x squared as x to the power of minus 2. Then the derivative of x is 1, and the derivative of x to the power of minus 2 is minus 2x to the power of minus 3. And then minus 2x to the power of minus 3 can be rewritten as minus 2 over x cubed. So the derivative is 1 minus 2 over x cubed. Part 2. F of x equals 2 over root x minus 1 over x to the power of 4 plus 5. So 2 over root x gets rewritten as 2x to the power of minus a half. Minus 1 over x to the power of 4 gets rewritten as minus x to the power of minus 4. And plus 5 stays as plus 5. Then we differentiate. So the derivative of 2x to the power of minus a half is minus x to the power of minus 3 over 2. The derivative of minus x to the power of minus 4 is positive 4x to the power of minus 5. And the derivative of 5 is 0. So we rewrite minus x to the power of minus 3 over 2 as minus 1 over x to the power of positive 3 over 2. And we rewrite 4x to the power of minus 5 as 4 over x to the power of 5. So again, this is using our indices rules or our powers rules. So it might be a good idea to recap those when you're learning differentiation. Evaluating derivatives. Often we have to evaluate a derivative for a particular value. If the function is given as y equals f of x, then dy dx represents the derivative of the function, and dy dx at x is equal to 5 would represent the value of that derivative when x is equal to 5. Similarly, if f of x represents a function, then f prime x is its derivative, and f prime of 5 is the value of that derivative when x is equal to 5. Part 1. If s is equal to 3t squared plus 5t minus 7, find the value of ds dt when t is equal to 2. So s is equal to 3t squared plus 5t minus 1. So ds dt, so we're going to differentiate s with respect to t. So the derivative of 3t squared is 6t. The derivative of 5t is 5. The derivative of minus 1 is 0. So ds dt, the derivative, is 6t plus 1. So we're interested when in what the derivative is when t is equal to 2. So we swap t for a set of brackets, put in 2. 6 times 2 is 12. 12 plus 5 is 17. Part 2. If f of x is equal to root x plus 3x, evaluate f prime of 4. So f of x is equal to root x plus 3x. So root x is rewritten as x to the power of a half. So then the derivative of x to the power of a half is a half x to the power of minus a half. And the derivative of 3x is 3. And a half x to the power of minus a half can be rewritten as 1 over 2 root x, and 3 stays as 3. So now we want f prime of 4, so we swap this x for 4. We could swap it for a set of brackets and put 4 in, but it's not going to change the value. So we have 1 over 2 root 4 plus 3, which gives us 3 1/4. So ds dt is the derivative of s with respect to t. dA dr is the derivative of a with respect to r, and so on. Second derivatives. Second derivative is when we differentiate a derivative. So we differentiate a function twice. So the derivative of dy dx, so the derivative of the derivative, that is d dx, dy dx, is denoted by d2y dx squared, and is called the second derivative of y with respect to x. d2y dx squared is pronounced d2y dx squared. The derivative of f prime x is denoted by f prime prime x or f double prime x, and is called the second derivative of f of x with respect to x. Note, the second derivative, d2y dx squared, is not the same as the square of the first derivative dy dx. In other words, d2y dx squared is not equal to dy dx to be squared. If f of x equals x plus 1 over x, find the second derivative and find f double prime of 2. So f of x equals x plus 1 over x. So 1 over x can be rewritten as x to the power of minus 1. The derivative of x is 1, and the derivative of x to the power of minus 1 is minus x to the power of minus 2. So this is the first derivative. So to get the second derivative, we're now going to differentiate this. So the derivative of 1 is 0, and the derivative of minus x to the power of minus 2 is positive 2x to the power of minus 3, which can be rewritten as 2 over x to the power of positive 3. So now we're going to sub in 2 in place of the x, so we get 2 over 2 cubed, which gives us 2 over 8, which is a quarter. Part 2. If h is equal to 10 plus 30t squared minus 4t to the power of 3, evaluate d2h dt squared, or the second derivative when t is equal to 3. So h is equal to 10 plus 30t squared minus 4t cubed. So dh dt, the first derivative, so to differentiate 10 we get 0, to differentiate 30t squared we get 60t, and to differentiate minus 4t cubed we get minus 12t squared. So this is the first derivative. Next we want the second derivative, so d2h dt squared, the second derivative. The derivative of 60t with respect to t is 60. The derivative of minus 12t squared with respect to t is minus 24t. Now we have the second derivative. We swap any t's for brackets and put 3 inside the brackets. So we get 60 minus 24 times 3, which is minus 12. If y is equal to x to the power of 4, show that 4y over 3 d2y dx squared minus dy dx to be squared is equal to 0. So we have y is equal to x to the power of 4. The first derivative, dy dx, is going to be 4x cubed. So bring the power down in front, reduce the power by 1, so we got 4x cubed. And then the second derivative, so differentiating 4x cubed, we get 12x squared. So bring the power down in front, reduce the power by 1, we get 12x squared. So now all we have to do is sub these values into this formula or this equation. So 4y over 3, well, we swap the y for x to the power of 4. So we have 4x to the power of 4 over 3. And then d2y dx squared over dx squared, we swap for 12x squared with brackets. Bring down the minus. And then dy dx to be squared. So the dy dx, we swap for 4x to the power of 3. And that's all to be squared. Then we simplify. So 4x to the power of 4 over 3 multiplied by 12x squared. Well, 12x squared is the same thing as 12x squared over 1. So we do top by top, bottom by bottom. So 4 by 12 divided by 3. So 4 by 12 we get 48. 48 divided by 3 we get 16. And then x to the power of 4 multiplied by x squared, multiplying powers with the same base, we add the powers, so we get x to the power of 6. And then 4 squared is 16, and x to the power of 3 raised to the power of 2, we multiply the powers, so 3 times 2 is 6. So we get 16x to the power of 6 minus 16x to the power of 6, which cancels. So we end up with 0 as required.